Hello dear students, this is Mr. Izzat Muhammad. Today we are breaking down some kinematic equations of motions. Let's get started. First example, cyclist is traveling directly east through a valley, which is completely flat at the velocity of 6 meters per second. So this is a final initial velocity Vi. Accelerate at 2 meters per second square, and this is acceleration A for 4 seconds, and this is T. We are asked here to find or to calculate the distance that the cyclist covers in 4 seconds. Number B, we are asked to calculate the cyclist's final velocity Vf. So first of all, we are going to write our known quantities, or list the known quantities. Initial velocity is 60 per meters per second. Acceleration A 2 meters per second square time T. Displacement and the final velocity. This needs to be calculated. Step number 2, you are writing our blank formula. Our blank formula will be the second equation of motion, which is our third equation of motion. S equals ut plus half et square. Step 3, we substitute in this blank formula. S, which we are asked to find, equals ut, u initial velocity equals 6 meters per second time equal 4 plus half times 2 times 4 square. That gives us 44 plus 60. So S is going to equal to 14 meters. Okay, this is the first thing we are asked to find or to calculate. B, calculate the final velocity. Step 1, we are going to list the known quantities. Initial velocity 6 meters per second, acceleration 2 meters per second square, time is 4 seconds. Final velocity, this needs to be calculated, or unknown value. Step number 2, we are going to write our blank formula. In this problem, the equation that links Vu and Vua and T is equation 1. V equals U plus AT, equation 1, or equation number 1. So we substitute in this blank formula. V is going to equal to 6 plus 2 times 4. Final velocity is 14 meters per second. Number C, calculate, or point C, calculate the time T for B to catch up to A. Step 1, list our known quantities. For cyclist A, initial velocity 18 meters per second, acceleration 0 meters per second square, time T, displacement S. A. For cyclist A. For cyclist B, we are going to list the known quantities for cyclist B. Initial velocity 0 meters per second, accelerations 1.5 meters per second square, time T, displacement SB. Step 3, write expressions for cyclist A and cyclist B in terms of their displacement. Cyclist A's motion can be expressed by SA equals UAT plus half ET squared. SA is going to equal ET plus 0. That gives us ET t. Cyclist B's motion can be expressed by SB equals UBT plus half EBT square. As we know, U is equals to 0 plus half plus 1.5 plus t square, that equals 3/4 t square. So step number 4, equate the two equations and solve for t. SA equals SB, that gives us 2 square minus 24t equals 0. So t equals 0 or t equals 24 seconds. Let's move on to the other part or the next part. Example number 2. A science museum designed an experiment to show the fall of feather in a vertical glass vacuum tube. The time of fall from breast is 0.5 seconds. Use an equation to calculate the length of the tube. First of all, we write our known variables or list the known variables. A equals 9.8 meters per second square, U equals 0, T equals 0.5 seconds, and L we are asked to find or needs to be calculated. Step number 2, the equation that links those variables. The equation that links these variables is equation 2 of motion. S equals ut plus half et square. So L equals half gt square. L equals half 9.8 times 0.5 square. So L equals 1.2 meters. Let's move on the next part. Examiner tips and tricks. This is one of the most important sections of this topic. Usually there will be one or more questions in the exam about solving problems with the kinematic equations. The best way to master this section is to practice as many questions as possible. You should practice as many questions as possible, as you are going to solve one or two questions of kinematic equations of motion in exam. Watch out for the direction of vectors, displacement, acceleration, and velocity. Tip number 2, you should watch out for the direction of vectors. Displacement, acceleration, and velocity. Take a single direction as positive, and hence the opposite direction is negative. Okay, tips number 3, you may sometimes see these equations referred to as Soviet equation. Okay, motion graph. This part or this topic is revolving around displacement time graph, velocity time graph, and acceleration time graph. Displacement time graph, velocity time graph, acceleration time graph. The motion of an object can be analyzed in terms of position, velocity, and acceleration. So these are all related to each other by gradients and the areas under curves. So motion of an object can be analyzed in terms of position, velocity, and acceleration, d, v, and a. Those are all related to each other by gradients and areas under the curves. Three types of graph that can be represent the motion of an object are. You should solve as many questions as possible in this part. This is a very important part, and these variables you should be familiar with them as you are going to use them to solve equations. Okay, displacement time graph. On displacement time graph, slope equals velocity. The y-intercept equals the initial displacement. A straight line represents constant velocity. Curved line represents acceleration. Positive slope represents positive direction. Negative slope represents negative direction. A zero slope horizontal line parallel to the horizontal line represents a state of rest. The area under the curve is meaningless or has no value. So this is the graphs you should be familiar with. Straight line with positive slope, displacement and time gives us acceleration, displacement and time graph for increasing acceleration, displacement and time for increasing velocity, displacement time graph for constant velocity. Velocity time graph. On velocity time graph, slope equals acceleration. In velocity time graph, slopes equals acceleration. The y-intercept equals initial velocity. A straight line represents uniform acceleration. Curved line represents non-uniform acceleration. Positive slope represents positive direction. Negative slope represents negative direction. Zero slope horizontal line parallel to the horizontal axis represents motion with constant velocity. And finally, the area under the curve equals the change in displacement. You know the difference here between velocity time graph and displacement time graph, that the area under the curve here is equal to the change in displacement, but the area under the curve in displacement time graph is meaningless. You should be familiar with these figures as they are very important. First, velocity time graph for increasing acceleration. Velocity time graph for increasing acceleration. Velocity time graph for increasing velocity. And finally, velocity time graph for constant velocity that horizontal to or parallel to the horizontal axis. Vertical axis here represents velocity measured with meters per second square. Finally, acceleration time graph. On acceleration time graph, slope is meaningless. y the y intercept equals the initial acceleration. The y intercept equals the initial acceleration. A zero slope represents a constant acceleration. Area under the curve equals the change in velocity. You should be familiar with these figures as they are very important. First, acceleration time graph for increasing acceleration. Acceleration time graph for increasing velocity or zero acceleration or constant acceleration. Acceleration time graph for constant velocity or zero acceleration. A equals 0. How displacement, velocity and acceleration graph relate to each other. Acceleration can either be uniform or non-uniform. Uniform, i.e. a constant value, for example acceleration due to gravity on Earth. Non-uniform acceleration, a changing value, for example an object with increasing acceleration like a car when you press the pedal. That's all for today. See you guys in the next lesson with motion of punching ball.